Okay, so today we're going to add another little piece called adapters. And okay, so what are adapters about? Well, it's it's kind of like in the cartoon, as you can see. They they kind of had a little bit of a mismatch there. And so that's basically what's going on. Like what we've seen is that we can create these event graph components, each of which is its own encapsulated thing. So this encapsulated idea is really important, as I've been haranguing since last quarter. And so the idea is that each event graph component it completely keeps track of its own state, independent of any other state. And because of that, you can have multiple copies of the same event graph, and we'll actually see an example of that. Now, okay, so that's sort of one thing. But the other piece is when you have components like that, and I'm using components instead of objects because the idea of components is that they're interacting with each other to a greater extent than, and in a more loosely coupled way. By loose coupling, I mean an example of tight coupling is if you're talking about objects, the way that one object communicates with another is that it invokes a method on the other. It gets a reference to it and it invokes a method on it. That's very tight coupling. Now it can be made a little bit loose through some abstraction, especially in Java. You have the concept of interfaces, and so you can be sort of you don't know the exact type of object that you're sending a message to, only that it implements a particular interface. Okay, so that's, but even that, it turns out to be more tightly coupled than is effective. Why? Because as you kind of build up all these different components, you want to start maybe connecting them in different ways than you'd originally imagined. And we'll see an example of that. The problem comes in now is that the problem is that we have an event that's one name, and we want that event to trigger an event of a different name in another component. That's what we want to do. Now we have the sim event listening idea, which is and the way it works in its most generic form is that whenever there's an event of a particular name and there's another component listening to that event, listening to that component, and it hears an event that matches one that it has in name and signature, then it triggers that. You've seen that both in some of the event graphs that we've talked about here, and you've seen it in the both in the simple server and also in the Renegade model that I've asked you to complete by today. So there, the arrival process or the customer arrival process, whatever it is kind of kept separate. And that's what it kind of gives you. But that only works if the names and signatures match. So what if the signatures match, but the names don't? That's where kind of an adapter comes in. So, and then the remote people can't see it, but as you can see, there's this bevy of adapters here. Why? So because different computers have different types of connectors, and so you have this kind of spaghetti list of adapters here. So that's a little bit of it. It's the same idea though. Like each one of these adapters, for example, here's one. I don't know what that goes to, but okay, here's one that goes to a. It looks like a USB-C, and on the other end is an HDMI. So if I want to connect an HDMI to the laptop, then I need, in fact, an adapter, which has the USB-C at one end, a male, and then a female HDMI at the other end, so that I can plug the thing in. So that's basically what's going on here. And what do you need for the adapter to work? It's not just the connector, but you also need an internal. The wires have got to line up in the right way. So presumably the adapter is done that way. So what that looks like is well, there's this thing we're going to call it an adapter, and it's going to adapt an event of one name to an event of another name, but the signatures still have to be the same. Okay, so basically it just converts the name of an event in the source to a different name for the listener. So here's the kind of generic notation for that. So here we have one component, and we have an event A that schedules an event B in the first one. And then here we have an event C in the second component, and it wants to schedule another event D. So what we want is who decides what you want? I mean, you do, the modeler. So we have an event in one component, and I want event B in this case to trigger event C in this other one. Now, out of the box, just with a regular old listener, that can't happen. So using just the ordinary listener idea, we're kind of stuck. Or well, what we would have to do, or I mean, we're not completely stuck. What we would do is we would just kind of write a little tiny component that would look like this. And it would basically hear a B, so it would listen to this guy and then be listened to by the second guy. So here's a way to do what we want without having to add any additional mechanism. So why have the adapters? Well, because what happened was there were so many times when this little paradigm was written that I mean, basically, if you what's an analogy? One of the things about on the East Coast sort of Ivy League schools have this the way that they built the sidewalk. Like I went to a public university, and they had these like the sidewalks were laid out in this rectangular fashion that didn't take you where you wanted to go. So it was a real pain. And so people kept wearing the grass out by kind of cutting across. So they got upset about that. So they put these fences up to keep you from doing that. And then the fences were just a height just when they would just kind of trip you if you weren't careful. But actually, one of the things that you may have noticed here is that they out in the quad they have it's basically rectangular, but there are a couple of paths that kind of cut through. So where did they come from? They come from people who kept cutting across and wearing a path out. And so what they did was they made a sidewalk where the path was. So that's kind of what was going on here. Is like, well, basically, people were writing so many of these things that it became evident that okay, there's something a little more. Let's just sort of make it easy, and that's where the adapter comes in. So This adapter, which is just a notation in event graphs, is you're saying, I want to take the event B and I want to turn it into an event C. So, and unlike the other use of this is that sometimes there might be events that I happen to have of the same name that I don't want to hear. I don't with regular sim event listening, I hear everything. But if I only want to hear particular events, then that's what the adapter does. So there have been times when I've actually adapted an event to itself by the same name because I had the right name, but there would be other events in the source that I did not want the listener to hear. Okay, so is the concept clear enough? And the other thing is that the signatures have to match. So if, for example, event C had an argument, this would not work. So you can't overcome that, and that's fundamental. So in other words, if I have something without an argument, and I want to basically schedule an event with an argument, I need some information to pass there. And so if I wanted to do something like that, then I knew if this component knew what that was, then I would want you'd have to kind of either schedule another event or have or do the other thing here in that second thing. Okay, so well here's an actual useful example. So now we've looked at tandem queues or various elements of that as one thing. But what's interesting is that given that if we have like an arrival process and just that simple server, which was only designed to solve the multiple server queue problem, well, why not instantiate two of them to create a tandem queue instead of having to do the other thing? Well, the problem is that what we want is we want the end service method, the end service event in one to schedule an arrival in the other. And so the adapter solves that nicely. Whereas if we just listen, just in general, sort of two copies of the same event graph listening, that almost never works. I can't think of a single case where that works. Why? Because an event scheduled in one is going to trigger an event in the other, and that almost is never what you want, almost never. So we want the end, so what happens in the tandem queue? Well, when we finish service in one, we immediately join the queue in the other. But that is triggered by the end service event in the first server. And we want to trigger the arrival event in the simple server. Okay, so that's what we want. And this is what does it. So now, okay, so this is kind of abstract. So let me just. Okay, now, let's see, I'm looking at the time here. I think I'm only going to have time to do this for the Java version. So the Python folk follow along as best you can. And I'll put it in the Python, but I don't think I'm going to have time to do that here. So now we actually don't have I don't have the simple server in this, but we have that entity server from last time. So I'm going to be a little bit lazy, and I'm going to just make another copy of that. So this is sort of, I'm going to test a tandem queue with adapter. Oh, it's not showing. Why isn't it showing? Huh. Well, it's. All right, I think I'm gonna have to. Okay, can everybody see NetBeans now? I don't know why it wasn't showing it. I was sharing the entire screen. Okay. Okay, so basically all I've done is I've just made a copy of the entity server thing that I was running before. And so what I'm going to do is I'm just going to make another copy of the thing. I'll tell you. It's called Entity Server 2. And we'll just use, we'll use the same, just the same parameters for that. That's kind of okay. And then just to, I'm going to uncomment my simple property dumper. But I'm going to make it, okay, when the simple property dumper has two constructors, the zero argument one is the, well, if I say true, what it's going to do is in addition to the state change, it's going to say which object it came from. So since I now have a number of different ones running around, I want you to, okay, so now how do I do the adapter? So I now have two entity servers. So I'm going to do this. This is going to work on the entity server because the end service event, if you remember, had entity as its argument, and the arrival also had entity as its argument. So I want the end service in the first entity server to schedule the arrival in the second one. And there's a class called adapter. The right one, yeah, the SimKit adapter. Where are you? And the way it works is the constructor, oops. Well, it has a zero argument constructor, which is kind of useless, but it has one where you say the event that's triggered and the event that you have there. And essentially that's just mimicking what the event, what the listener diagram was showing. And then instead of what we do is the term is to connect. And so we're going to connect our entity server to our second one. And that, well, we have all these statistics, but okay, so but we don't worry about that. But let's just I'm not sure if 10 will be enough, but we'll see. And let's make this verbose. Okay, so we're just going to run it for 10 time units, but in verbose mode with our simple, where's my simple property dumper? There it is. And I'm adding it to entity server, but I want to add it to everybody else too. And property change listener. And oh, let's just add it to everybody. All right, so hopefully if that works, the statistics, of course, are going to be meaningless. Okay, so we have a lot of stuff going on here. All right, let's make it a little bigger. Can we? All right, so all right, so we have 3 of these guys. So here's the entity arrival process. Here's our entity server, and it has an ID of 2. the next one has an ID of 3. So that's how we can distinguish them. So first we have the arrival. Then we have the run for the first server. Okay, number of available servers 2, number served queue empty. And then we have the run for the second one. It also has 2 available servers, hasn't served anybody yet. And then the next event is just our regular arrival, which is going to schedule an arrival with our entity. Okay, so far everything is just humming along. So arrival, there's a queue, delaying queue. We have a start service, schedules an end service at time 5. So we're going along, start service. Okay, so now notice, okay, so we had 2 servers, so there are now 2 end service events on the event list. So yeah, just one extra little thing to remember for systems like this is that, if, you know, there are never going to be more end service events on the event list than there are servers. I mean, it stands to reason, but it also stands to set. So if you ever see more, then you know that there's some logic off. Okay, so here we go. So here we have an end service event on the first server, that's entity server 2. And now look at the state transitions. So what did an end service do? It had the number of available servers go up to 1. The number served goes up to 1, and the time in the system, notice those are for entity server 2. That's why I had the simple property jumper say who it was. And now look at this. So the entity server 3 now has that guy going into this queue. And more than that, yeah, so and in addition to that, it scheduled a start service on entity server 3. So one of the things is that the event sort of got hidden, you know, or I mean, the event, as you can tell, happened, but it doesn't show up. Why? Because that arrival event never was on the event list. It was heard from the other component. Okay, so we have a start service, schedules the end service. And now it should have queue. Oh, but I think there was nobody in the queue for the other one. Okay, so here's another arrival. Oh yeah, there's the start service. And we have another end service, which again, now we have 2 available servers. We've served 2 time in the system, and now the entity is gone into the queue of this guy, and that's going to schedule that start service for that guy. And you know, just to kind of tap back to something that happened, remember when we did this by hand. So here's an example where the first entity finished, the second arrival actually finished first. So when you have more than one server at one of these, then the system as a whole is not first in, first out, even though the queue may be. Which piece is first in, first out depends on which piece you're looking at. If we're only looking at the queue, it's first in, first out. If we're only looking at one server, I mean, it's trivially first in, first out because there's only one. But if we have more than one server, then there's typically not first in, first out. Okay, but this is how the adapter idea works. And what that also does for us is that frees us up to have a lot more flexibility when it comes to our event graphs. So let me see if I can. Now, is this? I can't tell if this is can the remote people see the slides?
I can see it there.
Okay. I can't tell. It's kind of crazy. Okay. All right, so that's our tandem queue, and I use the entity server instead of the simple server, but same idea. And again, the key is I can now turn any event of a given name into an event of another name, and they will connect two components as long as the signatures are the same. Okay, so this was a model that was actually scheduled earlier, but actually fortuitously is more appropriate here because we're going to, is it? I don't know. Maybe it is. Maybe it isn't. I don't know. but this is nevertheless a useful model to look at the kind of assumptions that you need to make, as well as just a slightly more complex one. So the idea here is that we have parts that are arriving to a queue, and we have a worker, or possibly one of many workers, and they're going to disassemble the component into the part into two components, A and B, and then once they're separated, then they have to be inspected by another worker, by another now this is where we have to kind of make a choice. So supposing there's only one of these inspectors, and now all of a sudden they get handed two parts, one of type A and one of type B. So what do? I mean, you can't do both at once. So this is where you have to start making assumptions in the model. You can't just sort of leave it ambiguous. Otherwise, the model will not be able to it'll just be you have to make some kind of assumption, And here it's like, well, just put yourself in the place of this poor guy. You get handed two things. You have to do one or the other. And depending on their boss, they may make them do both at once, but that's physically impossible. Okay. So we're going to assume, our first assumption is that there's one that the person actually prefers to do for whatever reason. And we're going to look at that assumption, but just to kind of get the model going, we're going to say we're going to choose A over B as if they're previously idle. And then once they're, once you finish inspecting, then they're still going to go to a type A, just because those are the ones they prefer. That's the assumption. Okay, so let's look at parameters that we would need for this. Now here we have two different types of workers. So in a way, this is kind of like this is almost like a tandem queue, but it's got a little twist to it. The twist is that for every quote customer at the first station, there are now two customers going to the second station, and they're two different types of things. Okay, so we have a certain number of disassembly workers and a certain number of inspection workers, and they can't cross, you can't cross tasks. So if you're an inspection worker and you see this disassembly people have a whole lot of stuff, then too bad, so sad. Sometimes there are advantages of a union shop, but that's not one of them. Anyway, okay, so we need disassembly times. We need different inspection times for parts A and for parts B. So those are our parameters. And we're just going to have a basic model, not a complex one. Why? Because always start with a simple model. And this is as simple as you can do and capture what the requirements of the thing are. Okay, so state variables. Informed by our experience with multiple server queues, so I'll call it 0 and 1. So the available disassembly workers will start off with the total. The available inspection workers, likewise, will start with the total number of them. and they could be different. So, but now we have 3 queues. So, and we're back to counting. We're not, you know, we could do this as entities, but again, I always start simple. So we're just going to count. So we have 1 queue of the parts coming in, but then we have 2 queues, one for the disassembled A components waiting to be inspected, and one for the disassembled B components waiting to be inspected. Okay, so now what are we, you know, why are we even doing this? I mean, presumably at some point they're going to put them back together, but you know, and if you've ever been involved with some kind of maintenance like things like this, you'll hopefully recognize this as a simple version of this. I mean, most things are much more complex. You have many different things, and then certain ones may need to be repaired or replaced, you know, before you put them all back together on this. But again, we're just starting really, really simple. So as I said, we're going to assume that inspectors are always going to be inspecting A over B if given a choice. We'll have to come back to that. So, and what do? You know, if you were modeling an actual system, what would you do? Well, what you would do is you would maybe ask them what their policy is, you know, and model that. Again, presumably at some point there's going to be a reassembly of this, and that would be a different component. So that would be the just as the programmer virtue, the modeling virtue of that's not my job kind of comes in. So we're just modeling this one piece of it. Now, in a bigger application, you might have one team that's kind of working on one part of it and another team working on the other. And that's why these adapters become important, because the names that people give these events are completely arbitrary. Or not completely arbitrary, they hopefully have something to do with what the event has to do. Okay. And then, given our experience with this sort of arrival thing, the arrival of parts are going to be modeled with another component. So let's look at the kind of events that we would be having. So the usual way of or the approach that I espouse and all is start with the run event. So we have a run event, and in the run event, the state transition is just initializing all our state variables. So we're going to initialize our queues, initialize our available workers, and then that's what we have. Then the idea is we pick a state. So let's pick the state Q, the part Q, and say, what is it that could cause that to change? Or when is the arrival of a part? And so I'll call it part arrival. We could call it arrival, we just don't call it late for dinner. So that just increments the Q. And then what else can it change? It could decrement. And this should look fairly familiar. And then if we pick another state, say the number of available disassembly workers, then we would lose one when we start to disassemble, and we would gain one when we finish disassembling. But now notice that let's take another state. Let's say the number of available components of type A. What is it that could cause that to change? Well, we already have an event that does that. Namely, when we finish disassembling, we now have one more part, and now we can just put it in the queue of waiting component A parts. And likewise, if we lose one when we start inspecting a part of A, type A. And similarly, for a component of type B, we get one in the queue for components of type B. We get one when we finish disassembling, and we lose one when we start inspecting. And finally, for our number of inspection workers, we lose one when we start inspecting a B, and we also lose one when we start inspecting an A. We gain one when we end inspecting an A, and we also gain one when we end inspecting a B. So there's, that's just the way, it works. I mean, it's none of these are laws of nature. These are all driven by kind of how the model, how our model works. And now the tricky part. Okay, so the tricky part comes when we need to schedule things. So let's pick off some of the easy ones. So this top part here for the disassembly process is pretty much, we can, again, you want to be mindful of this. And it's almost identical, it's virtually identical to our multiple circuit queue. And so we can kind of pick that piece off there. And that's pretty much how it operates, because there's no, these workers are just involved with disassembling the parts, and that's all there is to that. Now, here, likewise, like when we start inspecting, it's going to take us a certain amount of time to do that. And similarly, it's going to take us a certain amount of time to do that, so we can kind of pick that off. Okay, so now let's take a look at, and here's where our assumptions start to kind of come in. We want to be able to schedule and start inspecting from an end disassemble event. Now, because we prefer A's, and that's an assumption, because we prefer A's from that, then all we need to check is there an available worker, an inspection worker? That's all we need to check. Now, is it possible, in addition to that, is it possible that this could be scheduled? So under what circumstance could we schedule beginning inspecting a component of type B once we disassemble? Or should I erase that?
There's an available worker and QA is empty.
If we have two available, and I can say strictly bigger than one, or bigger than or equal to two. Okay. So, and the important thing to point out about that is that, I mean, up until now, most of our conditions have been bigger than zero. But again, that's not a law of nature. Here, in this case, you're absolutely correct. The only way we can do this is if there are two inspectors available, because one is always going to pick this one. And if there's another one, though, hey, you got to do this one. But only if now I need at least two, so bigger than one or bigger than or equal to two, 6 of one, half dozen the other. Okay, so now when I finish inspecting A, because I prefer these A's, all I need to do is to check to see if there are more of the A's available, and that's the assumption. And now, okay, so now here's the other, now what about when I finish inspecting a B? Now you might be tempted to just immediately kind of do this, but that's not this is not going to be correct. Okay, so now what is incorrect about this? Exactly, yeah. In other words, if you finish inspecting a B, because you still prefer A's, if there's an A available, I want to be able to schedule that one. Okay, but can I still, are there still situations where I can inspect the B? Well, yes, if there are no A's, only if there are no A's. So if there are no A's but B's, when I finish inspecting a B, I can do that. And the same is true of this. In other words, I can schedule a B, but only if there are no A's and there are B's. Okay, so you see that there are some similarities, you know, that is, we can be informed by our previous experiences, but the idea is not to just boilerplate something, not to just kind of, because it doesn't always work. That doesn't work here, for example, because of the assumptions. And so I think, hopefully I got it right. Okay, yeah, looks like I did. Or no, sorry. With my drawing thing, I can specify to hop over. Anyway, okay, so now, and then okay, so now here, yeah, here's where the adapter things comes in. If what do I need to do if I want to drive this by with an arrival process? Well, an arrival process is going to create an arrival event, schedule an arrival event, but this wants a part arrival event. So now I can use an adapter to adapt arrival to part arrival, and now it'll work. Okay, but without the adapter, I'd either have to, you know, well, the choices are to have that little mini component that kind of just does that, and then or something else. And of course, if I was doing this with entities, then I would have to, you know, if I was doing it with entities, I would need something like the entity arrival process, and then, you know, then things would match up. Okay, but now here's the thing: is that we made an assumption about preferring component A's over B's. Why? To get the model working. And what often happens is that because the people in the system don't know anything about models, nor should they. A lot of times, what the policies are, what the rules are kind of hard to tease out. In other words, and then the other thing is that, okay, so you take this model, very simple model. You could kind of have it running literally in an hour or so from scratch, thanks to SimKit, or DeskPy, depending on what you're using. Now, what do you suppose is going to happen to your metrics as if you run it this way? Yeah, just loosely. Basically, the B components are getting screwed. I mean, what's going to happen is, the A's are going to be zipping through, and you're just going to have a big pile of B's. And why does that matter? Well, what is going on at the next station, at the next step in this process? I mean, if you're putting these things back together, then this policy is a pretty bad one. Why? Because you're not going to be able to create whole parts anymore from the new ones. So what can we do? What can we do to fix that? Well, one thing we can do is have another rule, and that rule it'll only apply. We can still say, okay, if you when you get a pair of A's and B's, you can still choose the A's over the B's. We could look at that as well. But really, the key thing kind of comes in here as the queues build up. How are you working the queues down? So a more reasonable one might be switch if possible. In other words, if I finish an A, my next one should be a B, if I can. And if I can't, then I'll do an A. So all that requires is just for these 4 events to have a slightly different criterion. So when I end inspecting an A, then I first check to see if a B is available. And if so, I'll start on that. And then I'll inspect another A only if there isn't one available, which could be the case. And likewise, if I end inspecting a B, then I want to inspect an A if it's available. And if it's not, only if it's not, and there's a B available, will I do that. And then now, just intuitively, if you run it this way, there's probably doing it. If I do it this way, it's likely, I stand a better chance of having a more balanced queues. In other words, the B queues aren't going to be building up quite so much. But just by chance, if the inspection times are kind of way off like that, another reasonable rule would be to choose the larger queue. And so what does that look like? Well, now my condition needs to look something like this. So when I end inspecting an A, then if the B queue is bigger, okay, so if let's see, can the remote people see this?
I can see it, sir.
Okay, thanks.
Have visual, thank you.
All right, so all right, so if the when I finish an A, if the queue for B is bigger than A, then I'm going to switch to B. But if they're equal, or if the queue for A is bigger, then I'm going to stick with the A. And so what this will do is this will keep the queues roughly balanced. So unlike the switching one, which may or may not, you could still lead to a lot of kind of unbalanced things that way. Here, this is going to be more responsive to kind of how the queues work. And it also, yeah. So, okay. So just to recap, we've talked about adapters. I showed how we could just use the components that we've already created, let's say for the simple server, in this case, the entity server, and use them to create a model that does a whole lot more. And for me, that's a good bang for buck. In other words, the virtue of laziness says that if I don't have to create any new components, but take the existing ones I have and just connect them in a different way, I have a model which does a whole lot more than I ever envisioned. The second thing here is the takeaway from this model are the implications for some of these assumptions, especially when you have multiple resources or resources like the workers in this case that are competing for different tasks. How they choose which task to do is something which needs to be reflected in the different typically in the different scheduling edge conditions is how you usually do that. Okay. And if there are no questions, we will adjourn.
I do have a couple of questions, but
Sure.
it's not really for the classes, just for you. Did you see, have you been receiving any of the emails that I sent regarding my code?
I did. I thought I responded to them. Let's see. Now I can't. Now who is that?
I'm sorry, this is Fidel.
Oh, when I don't. Well, I think I got one email from you, and I think I responded to it. You didn't get a response?
No, and that's a strange thing.
Okay, let me check.
Unless that was a response on like the assignment itself.
I'm not seeing any. Going back to last Friday. Oh, wait.
Sent items. Yeah, it would have been last Thursday after you told me that there were
Oh, yeah,
issues with
okay,
the
yeah,
submissions.
yeah, last Thursday. Yeah, I was my my Eclipse crashed, and so I haven't been able to check that out yet. But I'll do this this afternoon and get back to you. I can make sure I flag this so I remember.
All right. Yeah. I mean, it does look like that you had already scored it though. So I was kind of curious. I'm like, oh, okay, I guess the issue's kind of resolved, but
Yeah, well,
Yeah.
I saw your code. I had to kind of do something with it. So
weird stuff. Yeah, I know.
Yeah.
Eclipse has some very strange dependencies I found. So yeah, if there continue to be issues with that going forward, I will just make the switch.
okay,
to,
yeah, sorry,
NetBeans.
sorry for not getting back on that.
Yeah.
I was able to grade it. It just that I haven't checked the Eclipse thing. So
Okay, no problem. I have been making further commits to the repository though, and
Yeah.
of course, I'll
as
have
long as
the
it's
assignment
legit,
done
I'll be able
today.
to get it
Yeah.
somehow. Yeah.
Okay. Yeah. But yeah, if it's still not running through your automation out of the box, I'll make the switch to
Okay.
NetBeans this
Yeah.
week. Thank you. Oh, shoot, I think I did have a couple of questions on the assignment, by the way. I noticed at the end that you're looking for a number served, but there's no mention of number served as a state variable in the assignment itself. I was kind of curious. Do I just add that in?
Oh, is that the question? Well,
Yep,
okay, but there's a statistics object that's collecting the time in the system.
right.
And the statistics objects have an attribute called count.
Okay. So that's already handled internally there.
Yeah.
Okay, cool.
Is
Works
that
for
your
me.
question?
If that answers my question, then
Yeah.
yeah, then
Yeah,
I don't
yeah,
have to
yeah.
include that. Thank you.
Yeah. Okay, anything else from online? Okay, see you tomorrow.